Hello and welcome to the Data Engineering Podcast, the show about modern data management. When you're ready to launch your next project, you'll need somewhere to deploy it, so you should check out Linode at dataengineeringpodcast.com/Linode and get a $20 credit to try out their fast and reliable Linux virtual servers for running your data pipelines or trying out the tools you hear about on the show. Continuous delivery lets you get new features in front of your users as fast as possible without introducing bugs or breaking production, and GoCD is the open source platform made by the people at ThoughtWorks who wrote the book about it. Go to dataengineeringpodcast.com/GoCD to download and launch it today. Enterprise add-ons and professional support are available for added peace of mind. And go to dataengineeringpodcast.com to subscribe to the show, sign up for the newsletter, read the show notes, and get in touch. You can help support the show by checking out the Patreon page, which is linked from the site. To help other people find the show, you can leave a review on iTunes or Google Play Music, tell your friends and coworkers, and share it on social media. Your host is Tobias Macy, and today I'm interviewing Ozgun Erdogan and Craig Kerstiens about Citus, worry-free Postgres. So, Ozgun, could you start by introducing yourself?
Sure, I'm Ozgun. I'm one of the founders and the CTO at Citus Data.
And Craig, how about you?
Craig here. Came over to Citus to head up Citus Cloud and lead product efforts here at Citus.
And could you each start by describing how you first got involved in the area of data management?
I'll go first. Prior to Citus, I was at Amazon.com, and we had lots of data that we had to munch through. And Amazon was using relational databases, of course, but when we needed to scale, we turned to NoSQL and Hadoop-based solutions, because relational databases at the time didn't quite scale. And I was writing yet another service that relied on NoSQL at the time. And I realized everything that I had to do, all the application logic that I needed to build in as my interfaces, it was already accessible, available as SQL. So I figured, okay, hey, we have all this data. The good way to go about this is through writing SQL. Why not build a solution that makes relational databases scale?
And my background's probably a bit different. I think Ozgun kind of underselling it, being a very early engineer at Amazon, and the difficulties they face with kind of scaling, performance and the shopping cart essentially of Amazon.com. Interesting challenges. Mine was kind of more dumb luck. I was at a Fortune 100 company, wanted to try out this cool startup thing, and happened to end up at a company that at the time extended Postgres to essentially be a streaming database and essentially do MapReduce on data as it came in. So we were processing, potentially hundreds of terabytes a day on, a streaming database. And ahead of that, I knew about Postgres, kind of liked it, but I would say by no means an expert, and kind of just got, thrown right into it. After the fact, looking back, now 9 years later, I'd say I got pretty lucky of getting on the Postgres bandwagon pretty early on because it's a really, really great foundation to build on. But since that time, I've been, at data-focused companies, developer-focused companies, ran Heroku Postgres for a number of years. So now I've been in the Postgres ecosystem for a good little bit.
And can you start by describing what the Citus product is and how the project got started?
Yeah, sure. So I can give a little bit probably on what Citus is, and Ozgun could probably give a little bit more on the history since he's been around longer on that side. So Citus comes into play. So first, we're a pure extension to Postgres. We don't fork away from Postgres. We hook into these lower level APIs and basically turn Postgres into a horizontally, elastically scalable database. And what that means is you come to Citus when, you have a relational database that needs to scale out. So I think some of what Ozgun was talking about in that, NoSQL world of Amazon, what they looked at and had to do when they were trying to scale at the time, Citus does that just for a relational database, in this case, Postgres. So if you need better performance, for whatever reason, that's where Citus comes in.
And I'll go with the history of it. The history really goes back to our days at Amazon. We basically had all these data services, and we were using different technologies for different things. And I am a developer, and then developers have this notion, like we think in terms of imperative programming paradigms. So we think in terms of like for loops, if, all of that stuff. And I was writing one service after the other that used these NoSQL solutions or Hadoop-based solutions to make the data accessible to the application layer. And I realized SQL 1 is more accessible, because it's a declarative programming paradigm, many more people have an easy time using SQL. The only thing it didn't do, and it addressed all of these things that I was writing at the application layer, the only thing it didn't do was not scale. So I convinced the smartest people that I knew, and then we left Amazon to make SQL scale.
And I'll correct Amazon. I was going on one thing there. I think SQL is super powerful, useful. It's everywhere. I don't know that people enjoy writing it. There's still something horrible about the language, but overall, it's a very powerful and probably the right tool for the job for data.
Yeah, there's a great post from the folks at Timescale talking about the resurgence of SQL as the lingua franca of data solutions, both in the relational and non-relational worlds, because of the fact that it is so accessible and able to be read and understood by people who aren't necessarily developers themselves.
Yeah, I think that's completely spot on. I think if you look at SQL, it's not perfect, it's not elegant, but it's everywhere. It works. People understand it. It really is kind of the lingua franca.
And talking more about Citus in particular, I'm wondering why you chose Postgres as the foundation for building Citus on top of, as opposed to, for instance, starting with a brand new engine from scratch when you were trying to enable this horizontal capability.
Yeah, so I think if you step back from a macro level and think about, a mature database, how long does it take? Within the industry, it's pretty well regarded that it takes 10 years, sometimes longer, to get a mature database if you're building it from the ground up. Our goal with leveraging Postgres was actually to kind of cheat and shortcut that, right? By leveraging Postgres, we don't have to worry about all of these complex things under the covers, MVCC, transaction management, isolation levels, not to mention all the cool stuff, right? Not to mention full text search, GIS, rich data types, all those sort of things. Our goal really by extending Postgres was to shortcut that as much as possible. So Citus has been around a little over 5 years, and now we have people putting, very robust production workloads. So we've kind of cut that time in half by extending Postgres. I don't know if I missed some of the key things about Postgres you'd add in there.
I think that covers almost all of it, yeah.
And were there particular use cases or feature sets of Postgres that led you to use that as the foundation as opposed to something else such as MySQL or any of the other relational databases on the market?
I think the fundamental reason is PostgreSQL is way more extensible as a relational database than any other relational database engine out there. When we started working on Citus, some of these extension APIs were not publicly available, but we could still look into the code base and see, hey, this database is fairly modular. Here's the planner, here's the executor, here's the storage engine, here's the logging engine, and we can hook into them and extend them. Whereas in MySQL, I think the only thing we could extend or change or improve was the storage engine. So it was only possible to do this with PostgreSQL. The things that we were doing with Postgres, we wouldn't be able to do them with another relational database. They just didn't have the APIs and they just didn't have the modular design.
Yeah, and I think if you looked at, when Citus started, we're one of the more advanced extensions that exists. Probably the other really, really advanced one would be PostGIS, I would say. At the time, it was the early days of those extension APIs, but you could very much see where Postgres was headed and becoming more of a data platform, right? It's not just a relational database, but it's a platform you can build and extend without having to get the code directly into Postgres itself. So you could kind of see how it was shaping up in that sense.
And particularly with the different rich data types such as JSON and XML and some of the other extension capabilities, as you mentioned, it's become much more of a multi-model database as opposed to being purely relational, where you see people writing document-oriented layers on top of it just because of the underlying storage capabilities are so robust that it saves a lot of time, as you've mentioned, for implementing something that isn't necessarily what was originally intended, but because of those capabilities, it's still a well-functional and production-grade solution.
Yeah, exactly. And I think the only one of those kind of multi-model, modes that it didn't have was as a graph database. And I said that at a conference recently and got corrected of, hey, have you seen this extension for Postgres, which turns it into a graph database? So I think now it probably checks all the boxes of what could you want a database to be.
And if I understand the history of Citus correctly, I believe that when it was first started, it was actually a fork of the Postgres code base and then was converted into hooking into those extension APIs. So I'm wondering if you can discuss the reasoning for that transition as well as the transition from being a closed source to an open source offering.
Yeah, sure. Yes, your understanding is correct. When we first started, we didn't have all the extension APIs that we needed to access. The functions were there, but they weren't exposed as extension APIs. And in order to do what we do with Citus, which is basically sharding, replication, query parallelization, and query routing, we have to hook into almost every sub-module within the database. This includes the planner, the executor, basically extending the syntax to support distribution, and shared memory initialization, the error function, like an error and logging subsystem to clean up after ourselves. And we did that in a way that was still extensible. So we didn't go in and mess the Postgres internals or fork, but it wasn't an extension because some of the APIs weren't there. And over time, our customers started asking, hey, the extension APIs improved, and our customers started asking about the extension. So we said, okay, now is the right time. Now these APIs are powerful enough. So we converted Citus into a full-blown extension. And didn't look back, actually. The benefit to us is twofold. One is forking an industrial-grade database means when we forked, that we had to support both our responsibilities, which is the distributed execution part of things, but also what comes with Postgres. So any major upgrade changes, new features, security and data loss fixes, we had to reintegrate and then re-release. When we turn Citus into an extension, fully extension, we only can, like we said, okay, we're focusing on this functionality set, and then we don't need to release anything. Postgres fixed it, Postgres released it, and it's available to our customers immediately. So it had that huge benefit, and also our development cycles got faster, our release cycles got faster as a result.
Yeah, I think the thing about it is, being a fork, today, if we were to fork off, people wouldn't miss anything. But it's really about 3 years, 4 years, 5 years down the line. If you think of something like JSON-B, which came in, 3 years ago, I guess now, I almost don't talk to a person now using Postgres that's not leveraging it. And if you could just imagine, hey, if Citus was a fork as of 4 years ago, we'd have JSON, but no JSON-B data type. It becomes much, much less valuable when the next, whatever the new JSON-B is, when we replace JSON finally with some new, better data type. It would be really, really painful to miss out on that.
And you had a question on the decision to go open source. I think even from the beginning, we are very developer friendly. We had a good usage among the developer community, but then the fact that it was a fork and also closed source was a barrier to entry. And I think there is a lot to be said about the open source movement, having access to these technologies that were proprietary and super expensive back in the day. So we said this is the right thing to do. We should put Citus out there as open source, so anyone can benefit from it, and it's available to developers and to the bigger community at large.
And given that Citus is now an extension onto the Postgres database and is no longer a fork, I'm wondering how well it works together with some of the other sort of complex extensions such as PostGIS that you mentioned, or also Pipeline DB for streaming SQL, or the timescale extension for using Postgres for time series metrics and data types.
Overall, it works quite well. In fact, our customers use extensions that I personally haven't heard about every now and then. So because of the way we hook into the APIs and because of the way in which we communicate in between the machines, it generally works quite well. We have customers using PostGIS. I believe Pipeline DB is becoming an extension, or is about to, has very recently. So I think when it becomes, or the moment it becomes an extension, the two could work quite well. And I'd say the same thing for timescale. At an architectural level, there is no reason not to use them together. We haven't tested it, but it should work.
Yeah, it wouldn't surprise me if someone out in the wild, because, both are open source and they're free to use, have tested. Mm-hmm. We have people show up like that all the time. We have lots of customers and users in production with PostGIS. And as Ozgun mentioned, there's crazy ones that show up every week that we hear about or get requests for. But in general, because of these extension APIs can be layered on top of each other, they can work quite well.
Mm-hmm.
And for the distributed and clustering capabilities, I'm wondering if you can do some compare and contrast between how Citus operates and the functionality it provides as compared to things such as the PostgreSQL distribution or the Postgres compatible Aurora service from Amazon.
Yeah, sure. So I think in some ways we're, similar. In other ways, we're very, very different. So like for PostgreSQL, it attempts to stay very, very close to the Postgres feature set, including kind of like ACID transactions across all the data, which Citus now has full support for. But PostgreSQL really kind of plays a price in terms of overhead and availability. So with PostgreSQL, there's a global transaction manager, which has to be involved in every single transaction. And essentially in the real world, what that means is multiple network round trips for kind of every single query or transaction that happens. And the result is, if you have a single node failure, it has the potential to bring down the entire cluster because there is no built-in replication around that. So it works in some ways of scaling out when you need much, much more data, but it's less so when, hey, I need much, much greater performance. So most people come to Citus when I'm outgrowing very much a single node relational database and I need better performance. Ozgun, you might be able to chime in a little bit more on Aurora. Aurora kind of hooks in and changes that underlying storage layer. You probably know a little bit more of the details there.
Yeah. I think there are a couple of differences between Citus and Aurora. One is, as Craig mentioned, Aurora ultimately follows a shared storage model where you have one machine that does the writes, and then underneath the covers you scale out the storage. But if you're running a query, that query still runs on that single machine. If you're doing a write, that write still needs to go through a single master node, and it is the one that actually does the writes. So in terms of scale out capabilities, it scales the storage engine, but it doesn't necessarily scale the CPU or memory part of it. And in addition to it, Aurora is a fork of Postgres, and it uses proprietary technologies underneath on the storage level to give this functionality, whereas Citus is an extension and Citus is open source.
Yeah, and I think we've actually had customers, when I started at Citus, I was like, look at Citus when you're at 2 terabytes of data or 1 terabyte of data. And I've been amazed that we've had customers come over much, much earlier. It kind of like, I'm like, I don't know if you need Citus, just scale up to a bigger instance because that's the easiest thing to do. But we've had customers move over at 100 gigs and 50 gigs of data, which easily fits on a single node, easily fits all in memory on a single node, RDS instance. But they saw much, much greater performance benefits on Citus because of the sharding, because of the parallelism. So we see actually people moving over earlier because of some of the other architectural benefits they get.
And digging deeper into how Citus enables that replication and sharding, I'm wondering if you can just talk about the architectural approach that it uses and how that has evolved over the time that you've been building and maintaining it.
Citus at a very architectural level is a shared nothing architecture. So basically you add new machines into the cluster and then your performance increases linearly, you scale linearly. What that means is the way it is built under the covers is when you enable the Citus extension, we hook into the query planner, query executor, the transaction subsystem, and you tell as the user, like, hey, I have these 10 PostgreSQL machines. To you, it appears like a single PostgreSQL machine and a PostgreSQL connection string. But basically, the moment you say, hey, this table, I'd like to distribute this table, you tell Citus, say, I want to make this PostgreSQL table a distributed table, and you give us a sharding key. Behind the covers, we say, okay, now this has to be a distributed table. We take that sharding key and then we distribute that table, shard that table across the machines in the cluster. Later, when you run a query, this could be a transactional query or a different query, we say, okay, does this query have distributed tables? If it does, we hook in the planning stage. We replan the query for distributed execution. We parallelize the query across the machines in the cluster. Merge the results and give them back to the user as if it was a single node PostgreSQL database, but obviously all the work being split across the machines, being done in parallel.
And what are the failure modes that people who are running Citus should be aware of, and how does it handle the loss of a node? And particularly, if you were to discuss it in terms of the CAP theorem, where do you think it falls along that spectrum?
That's a good question. In terms of the CAP theorem, let me think just for a sec. I think you would consider Citus as a consistent, available system that in case of a network partition, that would just wait for the network partition to go away. I think if you just think of it in those 3 terms, in practice, I think of the CAP theorem as an approximation because there are many different dimensions to it, like what is the performance going to be like, and then how do you think of the ACID properties. But that I think is the trade-offs that we're making as a relational database. And I think other distributed databases are there. Relational databases make similar trade-offs. In terms of the failure modes, in the regular, the more standard failure modes where you lose a machine or two, or when you have network hiccups, or when you lose a disk, basically Citus comes with two replication models, but I'll describe the one that's more common, which is streaming replication. Every machine in the cluster has a streaming replica, and on Citus Cloud, when we lose one of those machines, we have an agent that fails over to the replica within seconds. So to the end user, the failure usually isn't visible, and then is handled automatically behind the covers.
And looking through the documentation and the sort of architectural diagrams, it looks like for being able to distribute the queries across multiple hosts, there's a coordination point of the sort of query planner that determines where the query is allocated to and how the data gets sharded. So I'm wondering, from the perspective of single point of failure, how does that get deployed? Does each node have an instance of that query planner that's able to use some sort of consistent hashing to determine the location of the data, or just curious how that functions?
Yeah, so there's really a few options there. So, generally, if there is that single point of failure, but what we're running is that streaming replica with high availability. So if that node fails, you've got a standby immediately ready to fail over. What we also do have is Citus MX, which is a masterless setup, so you can connect to any node. And the key there is just that we need that metadata of knowing which shards, which shards are on which nodes and how to route them accordingly. So with MX, we basically do a two-phase commit to keep all that metadata when there's any changes to it, and you can essentially connect to any node. The coordinator, in a sense, doesn't actually do that much work, isn't that intelligent. It kind of keeps that metadata of this resulting hash value lives in this node. Really, if you think about it, if you were to manually shard in an application, we're doing just that for you. You just don't have to rewrite it all in your application logic. We just hook into the planner and rewrite things.
And looking again through the documentation, it appeared that for somebody who is migrating from an existing Postgres database, there are some differences in the table structures and the ways that they construct their queries and are able to be compatible with Citus because of the distribution aspect of it. So for somebody who is considering that migration, what are the steps involved and what are the things that they should be considering as they go through that effort?
Yeah, so within Citus, there's really kind of three types of tables that exist. And I think Ozgun hit on one, right? The sharded tables. If you've got, and it really comes down to a big question of data model. To give kind of the typical product manager answer, like, how do you structure your data for Citus? It entirely depends on what you're doing with it. So one is that sharded table. If you're, a standard multi-tenant app, think of something like Salesforce.com, like that customer's data is only that customer's data. And the easiest way to do that is just shard by customer ID. And all tables get sharded by that, not just one table, but all of them by customer ID. And then they all get co-located down together. Then we have a couple of other types of tables. We have reference tables, which are smaller lookup tables that will broadcast to every single node. So you can easily join against them. Think of something like maybe a states table or zip codes that lives on every single node that you commonly join to. And then we have tables that just stay on the coordinator itself. So these might be internal admin tables, that sort of thing. And in general, what we see people do is kind of start at the one or a few tables that they're really having trouble scaling. And then as they go through, they start with those. Those are most likely sharded tables. Then they start to identify the relationship of other tables to those. Like, does this need to be on every node, or is this a sharded table, or is this just a local table that doesn't have any other relationship? Once you've kind of done that, there's just a simple function you call to specify a reference table or specify it as a sharded table. You run all this on Citus, and then your schema's completely set up and ready to go. On the application side, it depends a little bit on how much work you need to do. If you're sharding by like a multi-tenant app, if you have that, customer ID on every query, you don't actually have to do any additional work. It just works. If you're doing very, very complex aggregations, it depends a bit. And Ozgun could probably speak a bit more on the SQL coverage if you're doing complex things like CTEs and how that works in a distributed system. There's more and more support coming in time for that. And then on the cutover side, we have some tools that actually live replicate from an existing Postgres instance to Citus. We just a couple of weeks ago had a customer cut over a 4 terabyte database with I think like 1 to 2 minutes of downtime. So we're able to do that actual cutover, which is a big concern for people. When you've got 4 terabytes to dump and restore a database could take days, possibly, at a minimum several hours. So we built a lot of tooling to actually do that cutover. But I don't know if you have any extra you want to add on the kind of SQL piece on those complex SQLs and that kind of thing.
I think the only thing that I'll add on that is more kicks in when you are looking into the real-time analytics use case, or maybe a bit into data warehousing. We have way more coming with Citus 7.2. So we are for that use case when you're running very complex aggregations, or when you're running CTO operations that span across multiple shards and machines. Right now you need to do a few workarounds, but then that is going to change with the upcoming Citus 7.2 release.
And looking at the feature comparison matrix between the different offerings for Citus with the open source versus hosted versus on-premise, I'm wondering if you can just briefly explain how they compare to each other and how you determine which features to release to or withhold from the open source version as compared to the on-premise.
Yeah, so I think at the core, I'll start on the open source side. There, you get all of the sharding, you get all the scaling, you get all the performance of Citus. Like, we don't want to say, hey, you need to pay more to get the performance out of Citus. Like, it's there, it's open source, and it's, every week we have new people writing blog posts that we had no idea they were using Citus up and running in production, which is kind of cool. Like, recently saw, like, Hipmunk write a blog post of, how a sharded Citus cluster helped them improve performance. So it's great to see, it's kind of the cool part of the open source. The bad part is, we have no idea how many people are out there using it. Then what we have are kind of two other options. We have the enterprise license version, which has additional features really kind of around helping you run Citus in a production environment. So there's additional security controls in place. There's the shard rebalancer that allows you to essentially elastically scale nodes with zero downtime. And, if you're on your own, you could basically put in some engineering time and figure out things, or take your application offline, or do a number of things there. So we have people that run the open source community version in production, but we've really focused on building more tools into the enterprise to make it easier to run, maintain in a very available production environment on the enterprise side. And the third option we have is a fully managed database as a service. And here we actually had myself and the original engineering team from Heroku Postgres, where we ran somewhere around 1 to 2 million Postgres databases per customer, come over and build out a fully managed database as a service. And there we're running the enterprise edition for you, so you get all that benefit. Plus you get backups, monitoring, high availability. Basically our goal is to be not all of your DBA, but I would say like 75% of your DBA, so you can focus on things like, features, optimizing queries, indexing, that sort of thing. Basically, you don't have to worry about keeping the lights on. We do that for you. Which features go in which version? I would say any kind of core Citus performance, the basics of Citus, will continue to be in open source. Then in enterprise and cloud side, we'll continue to add more value-added features for running, maintaining, so that you can kind of do less and we're doing more of that for you. That's kind of our goal there. And we've actually seen customers that got to production on the open source version, then come over and say, this is running and it's fine, but I've got to have an engineer kind of, a DBA that's maintaining this, taking care of security patches, upgrades, all that sort of thing, and then come over and cut over to the cloud fully managed service side. So our goal there is basically to make it so you don't have to worry or think about your database, which we've seen a lot of customers kind of appreciate.
And on more of the operational side of things, one question that I have is around backups, where if you have a single node database, it's a fairly known quantity as to how to run the backups, where you can either replicate the write-ahead logs or take a snapshot of the disk and back up all of the actual database files, or use pgdump. But once you start scaling out horizontally across multiple databases and sharding that, it seems like it would add some complexity as to how to identify which hosts have the canonical sources of data, which ones are copies of each other, and make sure that you get a clean, accurate dump of the entire database for backup purposes.
Yeah, I think that's mostly spot on, right? Like it's a lot of the same principles apply. So one of the most popular kind of tools for backups, Wally, we have the engineer that wrote it, and we recently released WalG, which is a Go rewrite. So it's up to 7x faster on restores. So we're using a lot of those same principles of the base backups, streaming the write-ahead log to S3 every 16 megabytes or 60 seconds, whichever comes first. But then we do have some additional bookkeeping around which nodes have had backups at what time, what's the state of them. So in a sense, it's the same. In a sense, it's just multiplied based on the number of nodes and that extra metadata coordination you've got to kind of keep up with.
And we recently merged in a change, or about to merge in a change, where we basically do a 2PC distributed transaction across the cluster. The thing that helps with backups too, in the way that once we do that transaction and we're using PostgreSQL's 2PC, we can practically get the log sequence numbers. These are the one log sequence numbers from every node, and say, hey, at this point in time, this is a consistent backup. Each node was at this specific point in their log files. And through leveraging that information, because that gives us a consistent view of the cluster, we can back up to a particular log sequence number in each node and then replay from that backup to have a fully consistent and distributed backup. So this is a very recent change that either just merged or that's about to merge to establish backups not only on a single node, but on a distributed cluster that's fully consistent.
And again, in the operational sense, for somebody who is considering deploying the open source version, what are the sort of resource capacities that they should be thinking of in terms of number of machines and amount of memory, amount of disk, and the types of disk that they should be running on the different nodes or different types of nodes?
Yeah, I wish I had a perfectly clean-cut answer. It entirely depends on your workload. We have customers that run with huge disk with really low memory because of their workload. And we have people that run, more memory, lower storage, and try to keep their entire data set in memory. It really depends on your access pattern, your workload, what you're trying to do. Generally, what we have found is there's not a huge difference between a bunch of smaller machines or say 8 smaller machines versus 2 really large machines when it's the same overall resources. Citus actually handles a lot of that really well, of the number of cores in the system or the number of cores in the system. And it scales pretty elastically that way, and same thing for memory. It gets down into the details of how many cores do you have that determine your shard count and other thing. But a good resource there is actually to hop into our docs. And if anyone ever has questions on sizing, whether it's even on the open source or the enterprise version, we're usually happy to help. It's use case specific, but there's some good guidelines that we've seen based on, hey, this is your use case, this is your access pattern, here's the right thing. And we can get to those usually in just a matter of minutes with a few questions based on, tailoring it to the right use case.
And is there a minimum number of instances that you should be using for being able to deploy a cluster? And then also in terms of the network layout, should you be aiming for locating the instances fairly close geographically, or is it something that is capable of spanning multiple data centers for a sort of global availability?
Generally you start with at least 2 worker nodes and 1 coordinator node. Citus doesn't make a lot of sense when you're running it all on kind of a single node. So we see people start at 3 node setups and go as high as, do we have a customer with 100 nodes, or is it just 80 in production? We're right around 80, that 100.
Yeah, 80 to 100,
in production, and very, very beefy machines, and that's holding, I believe it's 890 terabytes of data roughly, so it's just shy of a petabyte. So we're comfortable at the petabyte scale. In terms of, setting up the kind of region locality, we generally do recommend that it's in the same kind of region availability zone for latency. That said, you could run Citus in a geographically distributed setup. Most people that are coming to Citus, though, they want better performance, and that's why they're picking Citus. Is I'm running into issues on my single node database and from a performance perspective. So we do see more so that Citus is located in the same region, short millisecond hops between each other, so that you can not have that kind of slow down performance there.
And beyond just the performance capabilities and the data storage capabilities that Citus enables beyond just the base Postgres, are there any other use cases that Citus enables which would be impractical to attempt in just a standard Postgres distribution?
No, I think any use case where your data set size is fairly large, so it wouldn't, PostgreSQL wouldn't be able to handle it on a single machine, Citus would help. And as Craig alluded to, the most typical use cases that we see is the multi-tenant applications or the B2B applications. These are operational workloads, real-time analytics where you need to ingest lots of data and then look at that data in real time. And also, if you're looking to combine the best aspects of NoSQL with the relational properties of Postgres, those are the most typical ones.
I think there are some unique ones, though, specifically around, parallelism and even without a large amount of data, one customer comes to mind. So Citus actually powers analytics for professional football. So if you watch Monday Night Football and there's some crazy esoteric stat that Tom Brady is 47% in his career when going against the Jaguars, when going for between 7 and 11 yards, like that just came out of a live Citus cluster. The amount of data there is it's a decent amount of data, but it's not petabyte scale. The difficulty and challenge there was the data needed to be sliced and diced in 10,000 different ways and needs to respond in less than 1 second, because otherwise you're sitting there kind of dead air. Hey, what are we talking about? So I think a lot of times when you have an explosion of variables in your data and you need to have a bunch of ways to slice and dice it, that's kind of one of the more, I would say, unique and kind of out of the box ways that Citus uniquely excels.
Yeah, when you're on air, and when you can't afford to wait 3 seconds, then that's a use case where obviously, that Citus excels,
And would it be fair to pit the capabilities that Citus provides against offerings such as Redshift or BigQuery that are focused at large-scale data warehousing with fairly low latency for interactive SQL requests?
Less so. So we do see, get that question a bunch. And I think maybe it's because, Citus supports JSON-B and then some of the others are still waiting on it. But less so. Citus is really focused on higher concurrency and much more kind of real-time responsiveness. And less so on, as Ozgun was mentioning, some of the, very, very advanced kind of SQL functionalities, window functions, and that sort of thing, which you often see in a data warehousing setup. So like as a rule of thumb, if you have an internal data analyst that's going to spend, 2 hours writing a query, run it, it's going to analyze hundreds of terabytes of data and come back in, 1 minute, which is a good, impressive time. One of the other two are probably the right tool. Whereas if you're, more predefined and you've got an end user. So I think the most common case we see is like when Citus comes in, like there is someone that's hitting a website somewhere that needs a response in less than a second. And you've got thousands, tens of thousands, hundreds of thousands potential users that need that kind of responsiveness, less internal analysts. So in some cases we have it come up, but generally not kind of head to head for the exact same use case. Does that make sense?
Yes. And what have been some of the most challenging aspects of building and maintaining the Citus extension, whether from the technical or the sort of advertising or sort of community aspects of it?
I think from the technical standpoint, probably at first and still getting a deep understanding of the PostgreSQL code base and the different modules, how they interact with each other and how they interact with Citus. Because what we're doing with Citus is fairly unique in that we're enabling all these distributed capabilities by hooking into the engine or all places within the engine. And the Postgres code base has been evolving over the past 20 years. It still evolves. It's very lively. And understanding what every module does and how it does it so that we can extend on that functionality has been the technically most challenging part. That challenge came with its own rewards, though. A lot of the functionality that Citus provides today would take years. Each feature would take years to build from scratch. By understanding it, we get them for free. And not only the features, but also all the tools built around Postgres, they just work. All your processes, everything that you use, all your binaries, they just work. But understanding all different Postgres modules in detail and extending them has been the biggest technical challenge.
Yeah, I think on the community side, it's simply that most people confuse us for Citus Data than Citus Data. That's probably the number one challenge there.
And what are some of the situations where you would advise against using Citus?
I think the biggest one is kind of coming back to a minute or two ago, that data warehousing use case. Like if you truly have internal analysts, you don't have a need for sub-second responsiveness. You don't have end users hitting the data. And there's always kind of exceptions where we uniquely fit in just because we are very flexible. But if you're just looking for a cheaper, faster data warehouse, we're not a perfect fit. We tend to kind of be more end user facing than most data warehouses are. So that's That's the number one I would say, probably. I don't know if you have others or if that's the big one.
I have one other one, which is if your data set is small and if it's going to remain small, like that is a lot of companies obviously grow, but then if you're going to if you're just going to have a gig of data, and if you're going to stay at a gig of data, not scale, you don't need to scale, use Postgres. Like Postgres is an awesome relational database for data sets that size. If you don't need to scale, if you're not growing, go with Postgres.
And you've touched a little bit on this, but what are some of the most interesting or impressive uses of Citus that you've seen?
I think one of them is basically this use case customer that Craig mentioned. Heap Analytics uses about a petabyte Citus cluster across many machines. And then what they do is, obviously, all these events data comes into their cluster in real time because they're capturing all events in mobile devices over the web. And then they're enabling complex queries, both like funnel queries, behavioral queries on that data in real time, in seconds. And all of that cluster is powered by Citus. It's a fairly big sharded database, about a petabyte in size. That's one of the impressive use cases with Citus. Yeah.
And are there any upcoming features that we didn't talk about yet that you'd like to call out that are coming in future releases?
The huge improvements to SQL for the real-time analytics use case, as I mentioned, is one. We're also looking at open sourcing more extensions for that real-time analytics use case. We have a lot of customers who use this hyperlog data type. It's an algorithm for count distinct approximation. And we find that our customers also need extensions such as top n or percentile. So we're going to be open sourcing a few other extensions that target that use case. And we have an exciting year ahead of us, but I don't want to give too much of the roadmap looking into the next year.
Yeah, I think the extension is going to be a really exciting area, especially when you look at distributed systems. Like things like count star, it's just slow and hard. And when you look at large-scale data, you essentially jump into this world of sketch algorithms, which are really, really close to 100% accurate, but not quite. And they can work well in single-node Postgres, but extremely powerful when you're able to like push things down, parallelize them in distributed systems. So hyperlog log 1 is an exciting one, and it's just fun to say too. But we've got a few others coming down the pipe that I think, for large-scale data, to be able to do things that otherwise were just unfeasible, that's one area that's pretty exciting.
And there was another extension that I came across while researching the show that it looks like you guys have released, which enables you to use Postgres as a column-oriented data store so that you can take advantage of some of those efficiencies in querying that would pit it up against offerings such as Cassandra for that type of data modeling.
Yeah. So we've seen a number of people kind of adopt and leverage CStore for that columnar compression. It's great on the compression, and then for time series data, uniquely performant. We've also seen with all the Postgres 10 stuff, people start to leverage time partitioning with Citus. So you've basically got a sharded setup, and then you've got time partitioning underneath, which is great for time-based data as well. So I think there's a lot of exciting things coming together. CStore is a pretty exciting one, and we've got some interesting things potentially coming with it. But it's always a question of how can we help you scale and get better performance, which is going to be a constant theme for us, I think, going forward.
Yeah, I would agree with that. Like for the product, looking into the next year, improving the performance across different use cases is a constant theme. Yeah.
And are there any other topics which we didn't discuss yet that you think we should cover before we close out the show?
Yeah. SQL scales, that's what I would say. Yeah, I don't think it's a topic. Well, maybe it's a broad topic in by itself, but SQL scales.
Yeah, actually, I would echo that. It was the one, and honestly, it was the one valid knock against SQL for the longest time was, hey, it's great. I use it, my application framework, whether it's Rails or Django or Hibernate, all work fine with it, but it doesn't scale. And I actually think, we're starting to change that narrative, and SQL, there's no fundamental reason why it can't scale. And it's nice to actually kind of have your cake and be able to eat it too.
All right. So for people who want to follow the work that you are up to at Citus, and personally, I'll have you each add your preferred contact information to the show notes. And as a final parting question to give the listeners something to think about, I'd like to get your perspective on what the biggest gap is in the tooling or technology for data management today.
Yeah, I think there's I don't know that there's a huge gap in the tooling necessarily. It's as much that there's such a proliferation of tools that there's a lot of glue and duct tape of chaining tools together. A long time ago, it was you had the relational database and that was all you needed. And now you have a pipeline of 5 different things that don't necessarily talk, flow, work well together. And for a data engineer, that makes sense. Where we need to get it to is that to be much more turnkey for someone that's not a data engineer, that's someone that's the app dev. I think for us, we see a lot of people come to us that they don't want to think about the database. They don't want to think about a complex data pipeline. They just want to focus on features, right? And we need to keep making that kind of within the industry and data products, keep making that easier and easier so that you don't have to have a PhD in distributed systems to understand how things work. That someone that just wants to write an app and have it scale and be able to send parts of their data to a downstream pipeline pretty easily can do that. So I think the key is continuing to simplify more and more versus building more and more advanced things. It's how do we kind of lower the bar so that more people can actually take advantage of these systems?
Yeah, I agree. And simplifying involves building more of the advanced things, so it looks simple to you, but behind the covers, it's like the system does the heavy work. Yeah,
As I tell the engineers, like, hey, I can write the user interface like just fine. Like the rest is just implementation details. Yeah. Ozgun loves it when I say that. He's like, yes, technically that is true, but
it's a lot of implementation details. Yes.
All right. Well, with that, I would like to thank the both of you again for joining me today to talk about the work you're doing at Citus Data. It's definitely a very interesting tool and platform, and one that I am interested to see how it evolves in the future. So thank you again. I hope you each enjoy the rest of your days.
Thanks so much. Yeah, great chatting with you.
Yeah, same here. Yeah.